If you look at most rigid body simulations, often there's an initial trigger that causes the rigid body simulation. You can look, for example, at a series of dominoes. You need to actually knock one down before the rest begin tumbling. And it's this initial trigger force or beginning animation that's really important to create the effect visually in the rigid body simulation. So with our actual rigid body system, there's a few ways to edit this initial state or trigger force. And we're just going to look at a few of them right now. So the first thing is you can actually animate the activeness of a rigid body object over time. So what we're going to do is just keyframe the sphere, translating on the x-axis over a series of frames, 30 frames. And we want to use this actual animation to derive a rigid body simulation. So obviously the easiest thing to do is just make it a passive rigid body object. I'm going to increase the mass a little bit and switch the collision type to bounding sphere here. So when it's a passive rigid body object, that means that this will act as an obstacle for the other rigid body objects, but it itself will not react to the collisions or any forces. So you can see it's using the keyframe animation 100% and destroying the tower. If we want to get something more realistic where the actual sphere ends up interacting with the collisions, what we have to do is animate it over time, its actual rigid body state. So what we can do is just go ahead a few frames to just before the collision occurs and go into the rigid body properties here, and we'll key it as a passive rigid body object. We'll go ahead one frame and then key it as an active rigid body object. Now what's going to happen is it's going to be a passive rigid body object. Just before the collision, it'll inherit the velocity and then become 100% under the control of the rigid body simulation. So you can see there it's obviously reacting to the forces and collisions. The other thing we can do is edit the initial state of objects to get a trigger for rigid body simulation. So we can just go to our tower and select one of the pieces, preferably at the bottom or something. And what you have on each rigid body object is the initial state PPG. And from here you can actually give it an initial velocity or angular rotation, or even set its position or rotation. So by default, it will actually look at the object's animation to derive the initial state. You can see it's checked on by default, linear velocity from anim. So initially we'll always look at the object's transforms to look for animation, and if it doesn't have any, it'll look at these settings. So at the moment these don't have any animation, so it's going to use this PPG settings. So what we can do is give it a bit of rotation, say on the x-axis, and we can play that back. So you can see there it's this initial impulse that's trying to rotate. What I can do is give it a bit of velocity too, so it'll actually translate initially. There we go. So you can see it kind of kicks out of place, and we can use that to get drive a specific rigid body simulation. So something breaking apart, the demolition of something. That was quite slow. So if we bring that up a little bit, make that happen a little faster, you can see we can get it collapsing quite a bit quicker. So there's all kinds of special effects you can do this way. We can make it kick up in the y-axis to kind of jump up and kind of give this, popping from underneath effect. So it's fun to kind of experiment with that, but that's just to give you an idea of how the initial state works.